Hi everyone, you're watching the Space Channel. Today, we decided to step away from our usual topics and discuss an interesting mathematical fact. From the school math curriculum, we know many unusual properties associated with the number 0, such as the rule that you can't divide by 0, or that 0 to the 0th power equals 1. And while division by 0 is intuitively clear, we simply can't split an object into 0 parts. The claim that 0 to the 0th power equals 1 raises questions. So why is that? Let's figure it out together. From school, it is known to everyone that when we raise any number to a power, then we obtain ones. And for all numbers except 0, this is quite simply proved. When multiplying and dividing powers with the same base, their exponents are added and subtracted respectively. Let us, for example, take 5 to the 7th power and divide by 5 to the 7th. According to our rule, this will equal 5 to the power 7 minus 7, that is, 5 to the 0 power. If we look at this from the other side, we have simply divided a number by itself, and according to the rules of division, this will equal 1. Thus, we come to the conclusion that 5 to the 0 power equals 1. Similarly, we can consider any other number and obtain the same result. But will this logic work with 0? However, many times we multiply 0 by 0, and in every result, 0 always appears. So 0 to an arbitrary power must equal 0. Suppose we divide 0 to the 5th power by 0 to the 5th. In that case, we will encounter division by 0, which is forbidden by the rules of mathematics, and therefore, the logic that works for all other numbers will be false in the case of 0. But all the same, 0 to the 0 power equals 1, and this has an entirely logical explanation. In some cases, it may be complicated. This is a pure mathematical problem, and there is no alternative. Let us begin with considering not exactly 0 to the 0 power, but simply tiny numbers. Let us take the function x to the power of x and compute its value for various small values of x, gradually approaching 0. At the same time, we will be constructing the graph of this function. At first, we will not see anything unusual. The values of the function will decrease together with the decrease of x. But at a particular moment, the situation changes, and our values begin to increase. Moreover, what is most important is that the smaller x is, the closer the value of x to the power of x will be to 1. Therefore, for continuity, it is logical to assume that at the very point 0, the expression becomes equal to 1. Thus, we obtain a graphical proof that 0 to the 0 power equals 1, and a more rigorous analytical proof involves a substantial amount of mathematical analysis, which is unlikely to be understandable and interesting to the majority of our subscribers. However, if this video receives 1,000 likes, I will record a separate video with a more detailed breakdown of this question. At this point, we could finish, but then, in the comments, those who have encountered higher mathematics will likely eat us alive, and they would be right. The thing is that in higher mathematics, there are a heap of examples when 0 to the 0 power does not equal 1, and it turns out as if I have deceived you all, but it is not so. And let us figure out why. We have already shown that the expression x to the power of x tends to 1 when x tends to 0. Still, in the general case, if we take two expressions, each of which separately tends to 0, and we raise one to the power of the other, then in the limit, it will not necessarily be 1. For example, such an expression, 4 to the power of minus 1 divided by x, all of this to the power of x, and it equals 0.25. Here, both the base and the exponent tend to 0, but overall this expression equals 0.25. Or the following expression, it tends to 0.6, repeating. Such examples can be given without number, and depending on which expressions are taken, the values will be different each time. How so, you will ask? Within the bounds of ordinary algebra, arithmetic, combinatorics, and some other branches of mathematics, we can calmly consider that 0 to the 0 power equals 1. Here, in fact, there occurs a veiled substitution of concepts. We replace the exact value of 0 to the power 0 with the value of the limit that we have just spoken about, and in simple problems, no errors arise. However, in the general case, especially in mathematical analysis, when finding limits, this does not work. In this case, they say that the value of the expression 0 to the 0 power is indeterminate. This is only one of the indeterminate forms that arise in mathematical analysis, and in each specific case, their values will be determined by their own methods. For higher mathematics, this is entirely normal, and indeterminate forms are considered quite often. Thus, what 0 to the 0 power equals depends on the context in which we consider this question. In school mathematics, it will be 1. And in mathematical analysis, we must resolve the indeterminate form. At this moment, mathematicians continue discussions regarding whether to present 0 to the 0 power as 1 in algebra, or whether it is worth considering each time the indeterminate forms. However, for all the time of my studies and professional activity, neither I nor any of my colleagues has ever had to encounter the expression 0 to the 0 power in applied problems. Therefore, for physicists, it is not important what it equals, but for mathematicians it is interesting, and so they consider such a problem. Well, that is all from me. Leave your comments under the video, subscribe to our channel, and put a like if you liked the video. See you next time.